Good morning, good afternoon, good evening. My name is Jen Guile with NGINX Product Marketing. Welcome to the second unit and second week of Microservices March, Kubernetes Networking. I am joined today by Andrea Giardini from our partner LearnKates. And of course, I've lost my mouse there for a second. There he is. Oops. Of course, it took my slides back to the beginning. All right, I'm here. Andrea, welcome.
Thank you very much. Good morning, good evening, good afternoon, everyone. Very happy to be here. Very much looking forward to the slides, the demo, the content of today, and very much looking forward to your questions as well.
Absolutely. So I know we have people joining us across multiple platforms, both YouTube, LinkedIn, and Twitter. Drop your questions in any of the three, and we have some of Andrea's colleagues as well as mine hanging out behind the scenes who will do their best to answer questions in the chat. And then we will also take questions toward the end of the session. We have about an hour today. And so Andrea's topic is exposing APIs with Kubernetes. If you're new to Microservices March, if you haven't registered, this is part of a 4-week series on Kubernetes networking. Last week was architecting clusters for high traffic websites. And then Unit 3 is on security. And finally, Unit 4 is those advanced use cases. Each of our units come with 3 components. The live stream, which you'll be completing here today, as well as a collection of technical reading and videos. So the blog for this week is linked in our video description. And I think our wonderful video producer, Marco, will drop it in the chat shortly. And then the third part, which does require registration, is a hands-on lab, which are available through NGINX.com. So that's NGINX.com/MM. And so you'll actually get to try out the lab that Andrea is going to be demoing today. So I see lots of hellos, greetings from across the planet. So I think we're about ready to get started here. For any of you who are registered for Microservices March and are part of the Slack community, definitely pop questions in Slack as well. And with that said, Andrea, I'm going to hand it over to you.
Thank you very much, Jen. Again, very, very, very excited to be here for this workshop about exposing Kubernetes API and how we can expose multiple services with Kubernetes and, of course, using NGINX Ingress Controller. But yeah, as of now, you can probably see my slides already. When we are exposing multiple applications, multiple deployments using NGINX, and maybe we want to fine-tune our deployment. We want to change the way we authenticate a certain service. We want to change the way we rate limit certain requests compared to others. The actual question that we need to ask ourselves is how many ingress controllers do we want to run? Do we want to run a single NGINX Ingress controller and define multiple routes in it? Do we want to instead run multiple ingress controller and keep traffic fully separate between the different applications that are running inside our system? During this presentation and this workshop, I will show you a little bit what are the different ways of exposing applications using Ingress NGINX. We will see what are the drawbacks of certain solutions, what are the advantages of other solutions, and how we can use the flexibility of the NGINX Ingress controller to expose our application to the internet in the most reliable and the most clean way, basically. First of all, let me very quickly introduce myself. My name is Andrea Giardini. I'm an instructor at LearnKates, which is partnered together with the nice folks over at the NGINX F5 for this Microservices March. I am a freelance cloud and infrastructure engineer. You can follow me on Twitter at Giardini Andrea. I publish sometimes content about Kubernetes, cloud technologies, and so on. Yeah, as Jen just mentioned, this webinar is part of the NGINX Microservices March. I invite you to follow the link nginx.com/mm, like Microservices March, of course, and to join our Slack channel in case you want to ask myself or any other of my colleagues questions about Ingress NGINX, about the workshops that we're doing today, that we have done, and that we will do also, of course, in the next days. So let's start from the bare minimum. The bare minimum that you need to install Ingress NGINX is a Kubernetes cluster. And right now, what you see in the slide is the easiest Kubernetes cluster you can create, an empty Kubernetes cluster. There is nothing running. As you can see, inside the cluster, there is no pod currently running, and this cluster has absolutely no deployment exposed to the public internet. So first step, let's start by creating our first application. In this case, let's take, for example, a simple web application, right? So I deploy my application, my deployment creates a pod. If you're familiar with Kubernetes and if you've followed already the webinar that we did last week, you're already familiar with this kind of concept. So we deploy our web application, and now we want to expose it to the internet. In order to expose our application to the internet, we of course need a service that in this case, we're not going to represent in the slide for reason of space, but most importantly, you need an ingress controller. In our case, we're going, of course, to use the NGINX Ingress Controller. And what is the next step? You have the ingress controller that is able to forward traffic from the internet to our application. We have our application. We have to define a way for the public to reach our application. In this case, we are going to apply to our Kubernetes cluster our ingress manifest that you can see right now on the slide. As you can see, this is an ingress manifest. You can see up here kind equal to ingress. The name of this manifest is name equal to app. So we are creating an ingress with name equal to app. And this is a very, very simple rule-based, host-based routing. I'm sorry. So we are basically saying all the traffic going to example.com should be forwarded to the service with name web on port 80 with prefix /. By applying this manifest to our Kubernetes cluster, the Ingress NGINX controller basically takes this definition and creates the corresponding routes inside NGINX to forward the traffic coming from the outside to our web application. And so what we will get after that is this nice flow. So the traffic can go from the public internet and reach our web application. Well, pretty nice, no? We just exposed our application to the internet. Our users can go to example.com and they will be forwarded to our web application. Now, this situation was pretty simple, very classical, nothing special about it. Now let's imagine that our team is developing more and more different products, different services, and so on. And at a certain point, we have the necessity of deploying another application. In this case, it will be an API. So very simple API server. We also, in this case, create a separate deployment. Of course, the deployment will create the pods. We will create a service. And at this point, we need to define a second ingress in order to route traffic from the internet to our API, right? And at this point, we have two possibilities. We can decide to go through the same ingress NGINX that we have already created. So we can create a separate ingress definition so that also the API server gets exposed to the public internet, or we can deploy a separate ingress NGINX. Let's have a look at both cases. And let's start by the simplest one. We will use a single ingress NGINX controller and add a field to our existing ingress. So in this case, I have a single ingress with two separate rules. Both of them are host-based. So you can see here on the left side of the slide, we are still doing the host-based routing on example.com, forwarding it to service web on port 80. But on the other side, we are still doing some host-based forwarding for api.example.com. And in this case, we are forwarding it to a different service. The service name is API, the port number is 80, the path is /. Once we apply this ingress definition, what happens is exactly this. So we created a second flow from the public internet to our API server. So at this moment, we have a single ingress manifest with two rules. One of them forwards all the traffic coming to example.com to our web deployment, and the other rule instead forwards all the traffic going to the API, to api.example.com to our API deployment. Pretty simple, right? Two rules, single NGINX Ingress Controller. But do you see any issue with this deployment? Do you see something that might go wrong? Something that, maybe you're not 100% sure if it's a good idea? Well, we will show it just in a second during our demo. But what we will experience is that since both the traffic of our web application and API are going through the same Ingress and NGINX, what could happen is that excessive traffic, for example, on the API, could impact our web application. And that's because we have a single NGINX Ingress Controller that is handling requests both for our API and for our web application. So if the API is flooded with requests, there is a risk that our web application does not receive as many requests and it might get timed out. Let's have a look at it together during this demo. I remember that all this material will be, I'm not sure if it's available already or it will be available soon online. So let's go through it. Let's have a look at what we can do. Okay, here we go. So on my right side of the screen, I just created a simple Minikube cluster. Let me do it again just to be sure. So kubectl get pod dash uppercase A. Uppercase A stands for all, so this command is going to print all the pods that are running in my Kubernetes cluster. This is a local Minikube Kubernetes cluster, and as you can see right now, except the core Kubernetes service, it's totally empty. Perfect. Now, step by step, let's do what we've seen right now in the slides. So we will first deploy our web application, we will deploy our API server, the NGINX Ingress Controller, and create all the routes, okay? So the first app that we're going to deploy is in this folder. Let's have a look at its definition. Perfect. Let me zoom in a little bit more. Fantastic. So in here, we have our first deployment. This one is the deployment for our API servers. As you can see, it has a single label, app equal to API, and it's running a single container. So this will create a single replica of a pod running a single container on port 9898. Together with it, down here, we can see that it's also creating a service. The name of the service is API and is forwarding all the traffic incoming on port 80 to the target port 9898. As you can see, this is a very classical deployment and service couple. So there is nothing special, nothing different than what you're used to see also in the most classical deployments out there. Next, let's have a look down here. So down here, I'm instead deploying my web application. We see that we have a kind equal to deployment. The name in this case is frontend with a single label app equal to frontend. And in this case, I'm still running a pod with a single container. Even in this case, obviously, I need to expose this deployment using a service. The service name in this case is frontend, is exposing a single port, the port number 80, and forwarding all the traffic on port 9898. Perfect. So what happens right now? Right now, we are going to apply this manifest with a kubectl apply -f demo 1 app.yaml, which is the file that we've just seen together. And once I click enter, here we go. We have the first deployment and the first service that are created here, second deployment and second service here. Remember that these first two are part of the API server and the second two are part of the web application. Perfect. So right now, we have deployed the two applications. So we have created the two deployments and we can actually see them in here, kubectl get deployments -a. Here we go. We have our API deployment and we have our front-end deployment. Both of them are currently spawning. kubectl get pod -a. Let's make sure. Oh, okay. There is something not working as it should. Let me quickly verify that. kubectl describe pod. Let me get the name and let me see if okay, it looks like there is an error in here. Maybe we should pick up the registration, the recording. I'm sorry, I'm not sure why it's failing to pick up the. Let me quickly try to delete the Minikube container and recreate it again, just to make sure that everything is clear and up and running. Okay, just 1 second. Sorry, this is the demo effect, right? It can happen every now and then. Just give me a second, let me restart it, and let's see if we are still having troubles, or if there is still, or maybe if the problem is solved. Booting up the control plane. But I can promise you that I tested it not so long ago, actually. So kubectl get pod-a. Okay, so this one they're running. kubectl apply-f demo on apps.yaml. kubectl get pod-a. Let's have a look. Status container creating. Let's have a look. It works better. Maybe it was a temporary issue. So right now, well, no luck. Let me try a third time. Minikube delete, and I will try right now to create it with the VirtualBox driver. Maybe that changes something. Driver equal to VirtualBox. Sorry for this delay. I promised that I tested it before, but you never know. The demo gods, sometimes they don't help, right? In this kind of situation. So I will try to create it again with a different driver. Maybe that fixes the problem. This basically will create a VM based on VirtualBox and run our Minikube cluster inside VirtualBox. What I was using before was the Docker driver, which was, which basically creates just a Docker container with Kubernetes inside. Let's have a look if we have a little bit more luck using VirtualBox. It could be that there is some networking problem. I don't think I have internet problems since all the streaming seems to go pretty well, but let's see. It could be that there is just a temporary error. Otherwise, no worries about that. We have a recording that we can pull out where I can show you what is being going on. Okay, let's see. Just a second. It might take a minute or two to download these images, but I really would like to show this slide because it's a very interesting demo in this case. Okay, looks like it's working. Let's have a look. kubectl get pod uppercase A. Some of them are running, they're coming up. And now let's cross our finger again. Demo 1, kubectl get pod-a. Container creating. Let's wait a couple of seconds. Okay, now the container are running. That's nice. I can see that all of you have been crossing your fingers really, really hard for me. Thank you very much. I appreciate it. Perfect. Let's go to the next step then. So just to wrap it up a little bit, sorry for the little inconvenience. We created two applications. One of them is the API application, and the other one is a web application. And now what we are going to do is install the Ingress NGINX controller. So basically what we're going to do is use Helm, which is sort of a package manager for Kubernetes. I'm sure many of you have used it already, to install the official Ingress NGINX chart. So this is the command that you should run. It will create a separate namespace NGINX, and it will run our Ingress NGINX in there. Let's have a look in just a second if kubectl get pod-n, because we want to have a look at the pods only in a namespace, NGINX. So even in this case, you can see that the pods are now creating. Let's wait just a second. It shouldn't take too long. But basically, as soon as this Ingress NGINX is up and running, we should be able to then connect to it and create all the ingress routes that we need in order for this Ingress NGINX to be able to serve traffic. Let's see that if we are lucky right now. That's perfect. We have our Ingress NGINX here. It's up and running, and now we are ready to deploy our ingresses and make sure that the application is reachable from the internet. So next, let's have a look at the ingresses that we want to deploy. We have them here in this file. They're exactly the same ingress rules that I've shown you already in the slides. So two very simple host-based routes. One of them says everything going to example.com should be forwarded to the service frontend on port 80. And the other rule says everything that you are sending that is being sent to api.example.com should be forwarded to the backend service API on port 80 as well. Now, let's give it a try to this. Apply the chef demo to ingress.yaml. Okay, here we go. We have the ingresses created. kubectl get ingress -a. Here we go. As you can see, we created a single ingress. This ingress name is first. The ingress class is NGINX, and the two hosts are example.com and api.example.com. Perfect. Now we can do a quick example just to make sure this ingress work. What we are going to do is run a small pod inside Kubernetes with an image of BusyBox, and we will try to reach these two different host names from within the cluster, just to make sure that the communication works. So what I'm going to run are two wget commands. The first one says wget. I am getting, as you can see, the service of our ingress NGINX ingress, and I'm specifying a single header host.api.example.com. If now I press enter, what do I expect? Well, in this case, I am asking for api.example.com. So I expect my NGINX Ingress Controller to return me an API-like example. In this case, if we press enter, here we go, we get a simple JSON file, which is what we were expecting. Now, let's test also example.com. As you remember, example.com is a website, right? So in here I have host header example.com. I'm setting another header, setting the user agent to Mozilla, just to simulate that I'm accessing it using a browser. And when I press enter right now, here we go, a bunch of JavaScript and HTML. That's exactly what I was expecting. So now we verified that when I am accessing Ingress NGINX using api.example.com, I'm getting forwarded to the API server. When I'm accessing Ingress NGINX using instead just example.com, I'm then getting forwarded to my web server. Now, let's have a look at a couple of things now. In here, what we have prepared for you is a nice dashboard that we can have a look at together. So if I go to, here we go, let me open the link. This is a simple dashboard we have built for you. It basically allows us to browse the web service. Okay. In this case, I will need to do a quick change right now because I was not using the VirtualBox driver before, but I need to do it right now since I have to, otherwise this demo will not work. Let me quickly do it. So I need to go to an ATC hosts, and say that the Minikube IP is actually the IP behind example.com. So in here, you can see that here there was the old IP that with the Minikube driver. Now I need to put this different IP, and I need to give it example.com and api.example.com. Sorry again about this little inconvenience. So clear. Now, what I need to do next is to point this dashboard to my web application. How do I do that? Well, basically what this dashboard will do is just ping our web service constantly and tell me if it's online or offline, as simple as that. So I will do HTTP :// example.com, and then I need to give it the IP Minikube service list of my Ingress NGINX. In this case, you can see Ingress NGINX service, the name of the service is main Ingress NGINX, the namespace is NGINX, is exposed on port 30610. So I copy this port and I need to put it in here. Now, if everything goes well and I press enter, here we go. So what this dashboard is telling me is that by requesting example.com on port 80 through our NGINX Ingress, I am getting the web page as it's supposed to be. So basically what the dashboard is telling me is that the website is reachable. The next thing we're going to do now is use software called Locust. Some of you might be familiar with it already. Locust is basically a software that is used for stress testing. Okay, so it's a software that makes a lot of requests that simulates user traffic on a certain endpoint, basically. So what we're going to do here is very simple. In here, you can see the configuration of this software. So we are going to send 5 requests to our api.example.com and a single request to example.com. So as you can see, this ratio is skewed heavily against api.example.com, meaning that our API server is going to receive way more requests compared to our web application. This is just a configuration file. You can see up here that, in fact, it's just a config map. Down here, we, of course, need to specify a deployment and a service because, right, we want to be able to access this service and see how it's performing, right? So let's apply this. kubectl apply-f demo free locust.yaml. As you can see, config map has been created, deployment has been created, service has been created. Right now, all we have to do is wait just a second, kubectl get pod-a, that our locust server is coming up. You can see here is booting, container creating. Hopefully, we're not going to have the same troubles as before. Let's try again to see if it's up and running, and here we go. The container is now, the pod, sorry, is now up and running. The next thing I need to do is open the Locust web interface. Here we go. So I'm going to move right now my terminal somewhere else, and I want to keep side by side these two tabs. One of them, remember, one of them on the left is showing me the health of my web application. So this tab on the left is just making requests to my web application and telling me if it's connected or if it's having problem. On the right, I have Locust that, remember, is going to make a lot of requests to the API server and very few requests to my web server. Let's see what happens when I start Locust. So let's say that we want to simulate a number of users of 1,000. So we want to simulate 1,000 users at peak concurrency, and we want to spawn 50 users per second. So we are pretty much trying to reach the limit of our web application, of our API server. Remember that Locust is heavily skewed towards the API server. In our host name down here, I'm just putting the service of my NGINX Ingress Controller. So all the requests from Locust are going straight to the NGINX Ingress Controller. Let's see what happens when I click Start Swarming. Here you have the charts that are showing you how much traffic is generated. As you can see right now, I have 0 failures, and it's going pretty well. But what I should start to see soon, if a demo goes well, is that, some requests are starting to fail. You can see it down there, right? You can see in here some requests are already starting to fail. Why is that? Because, oops, you can see what was just happening here on the left side. Our web application is not as healthy as it should be. It's sometimes timed out. Here we go, it timed out again. And remember that these requests are skewed towards the API server, not the web server. So what we have seen is that even if we are targeting the API server, our web server is impacted as well. And you can see it here on the left side. You can see that it's going between connected and timeout, and so on. So this is an issue, right? We don't want the web server to be made unavailable or to time out when the traffic is mainly routed to our API server. So how can we solve this problem? Let me stop this right now. Let's go back to the slides. So in the demo, what we have seen is that even if we were just targeting or mainly targeting the API server using Locust, even our web application was affected. As you have seen on the left side of my slide, our dashboard was telling us clearly that the web application was unresponsive sometimes. So every now and then it was timing out. Now the big question, how can we fix this? How can we solve this? Which solutions do we have to make sure that this doesn't happen again? Let's have a look. This is our current situation. Single NGINX Ingress Controller, 2 deployments, one of them for the web, one of them for the API, and we have the Ingress manifest that is now routing both requests through the same Ingress controller. So the traffic from the API and the web server are both flowing through the NGINX Ingress controller. This is usually not a problem, but what you can think about that is if my API server is receiving a lot of requests and Ingress NGINX does not manage to keep up with the traffic, of course, my web requests are going through the same Ingress controller. So this might cause a problem. This might cause issues, and this might cause what we have seen right now in our demo, that some of the requests going to the web server are not being processed in the right way, are not working correctly. Let's see how we can fix this. So the next step, what we will do is something simple. So first of all, we will remove the route from this NGINX Ingress controller. So we will let one NGINX Ingress controller dedicated to our web application, and then we will create a second NGINX Ingress controller. Notice that in the slide, I've now named them differently. We have the first NGINX Ingress controller, the one on the left, which is an Ingress class of NGINX-web, and we will talk about Ingress classes in just a second. And my NGINX Ingress controller on the right, which is an Ingress class of NGINX-API. What are Ingress classes and why are they needed? Ingress classes allow you to specify when you are pushing an Ingress manifest to Kubernetes, which Ingress controller should take care of that particular Ingress. So if I specify Ingress class equals to NGINX web, then this Ingress controller is going to handle the traffic for my application. If I specify Ingress class equal to NGINX-API, which is written over here, then is this NGINX Ingress controller that is going to handle my Ingress. How do I specify the Ingress class? I do it directly in the Ingress. As you can see, in the Ingress, there is a field called Ingress class name, and I can specify this field to NGINX web, NGINX-API, or whatever we might want to have in there. It's a configurable parameter that we can specify ourselves. So by specifying an Ingress of this kind, what we are doing is saying, well, I'm specifying an Ingress controller, an Ingress manifest, and this Ingress should be treated by the Ingress controller that is responsible for the Ingress class name NGINX-web. And this is what is going to happen. So at this point, I have 2 separate Ingress controller, NGINX web, NGINX-API. I have 2 separate deployments, web deployment and the API deployment, and the traffic is being forwarded for the web deployment through the NGINX web Ingress controller, and for the API deployment through the NGINX-API deployment. But let's take it up a notch, okay? Let's try to do something a little bit more complex. Well, the API server shouldn't be so overloaded, right? It should not receive as many requests. If somebody is trying to brute force us using a tool like Locust, we should prevent that somehow. And how can we do that? What about rate limiting? Rate limiting is a very nice functionality that is, of course, offered as well by the NGINX Ingress controller that allows us to basically limit the amount of requests that a certain user can do in a defined amount of time. So what are we going to do next? The idea is that we are going from this to create a couple of rules, to create a couple of rate limiting rules that will allow us to prevent the API server from being overloaded. How does it work in Ingress NGINX? This one, from what I've told, is a feature that has just come up with the latest Ingress NGINX. It has been in preview for a while, but now can be considered more than stable and ready to use. So what do you do is creating a policy. So in this case, these are all Kubernetes objects. So you just apply them as you usually do, kubectl apply -f. This policy is named rate limit policy. So I'm defining a policy that will rate limit certain requests. And look at here, this configuration parameter. They look pretty familiar, right? If you have already used NGINX outside Kubernetes, you have probably seen this kind of like naming already. What I'm saying in this case is I want the rate of my rate limiting to be 10 requests per second. So 10 requests per second is the maximum amount of requests that a certain remote address should do. In this case, I'm saying remote address because the key of this policy is binary remote address. So this will make sure that the same remote address does not hit the endpoint more than 10 times per second. Finally, I can also specify a zone size, which is the amount of memory that Ingress NGINX is going to dedicate for this particular policy. And then how do I apply this policy to ingresses, for example? How do I say, well, this ingress is rate limited and this ingress is not instead? Well, in Ingress NGINX, there is a concept of virtual server. And again, if you've used NGINX before the Kubernetes days, you're also probably familiar with what a virtual server is inside NGINX. So this virtual server manifest basically replaces our ingress. So it will sort of like act as an ingress for us. You see the kind up here is virtual server. We have a name that is API-VS. Then we specify an ingress class name. You can see the ingress class name in here. So we are saying this virtual server should be handled by the ingress class nginx-API. We're specifying the host, api.example.com. And then here you have it. We're specifying policies. And notice that this is an array. So this means that we can specify multiple policies at the same time. In this case, we have only one, the policy that we created previously, rate limit policy. And what is this ingress supposed to do? To rate limit all the traffic incoming and going to our API server. So we are just rate limiting our API server. We are not rate limiting our web application. So this is what we created. After applying all these resources, we have created two separate NGINX Ingress Controller with two separate ingress class. And on top of that, on the virtual server of the API server, we have also applied some rate limiting policies. What do we expect from that? We expect something like this. So we expect that since right now the two NGINX Ingress Controllers are separate, I should be able to use Locust again against my API server. And of course, the API server, Ingress NGINX will start rate limiting me, but the web application should always stay connected. This is the idea. Let's figure it out. Let's have a look how this looks like. So I'm going to bring back my terminal in here. This we can merge them together and clear this tab. So this is our current status. kubectl get pod-a. So these are all the containers that are running in my system. As you remember, the API server, my web app, Locust that we've seen previously, and that's basically it. Now, the first thing I'm going to do is delete the ingress that I've already created. So I will do kubectl delete -f demo to ingress.yaml. This will delete the ingress. So currently, if I go to kubectl get ingress-a, here we go, no resource found, empty list. I have no ingresses defined inside my cluster at this point in time. Next, I need to install the NGINX Ingress Controller, and I need to install two of them. So the previous one is going to be there, but we're not going to use it. Now we're going to install two different Ingress NGINX. We are going to install them, though, on two separate namespaces. So this one is the NGINX Web Ingress Controller. As you can see in here, I'm specifying that the ingress class of this ingress controller is nginx-web. So all the ingresses that I create with ingress class equal to nginx-web will be assigned to this ingress controller. And now I press enter. So the NGINX Ingress Controller is now deployed. Let's have a look. Have a look at it. Here we go. nginx-web, and here I have my pod running. Now, what I'm going to do is to connect basically this Ingress Nginx and to allow it to route traffic to my web application. So if I go on Vim, demo, for Ingress Web. So this one, remember, is an ingress just for my web application. How can I be sure of that? Well, the name is equal to frontend. The host is example.com. Service is frontend. The port is 80. But notice here, ingress class name, nginx-web. So I'm explicitly saying I want this ingress to be handled by the nginx ingress controller with ingress class name equal to nginx-web. So let's apply it. kubectl apply -f demo for ingress web. So if I now do kubectl, let me clear the screen. kubectl get ingress-a, I should see a single ingress, exactly. I have a single ingress named frontend, the host is example.com, and the class is nginx-web. Perfect. So we have created the whole flow for the web part, so for our web application. We have the deployment, we have the service, we have the nginx ingress controller, and we have created the ingress for it. Now we need to create a second ingress, the ingress for our API. This is a little bit more verbose, but it's very similar to what we've seen before. So basically, I'm creating an nginx ingress controller in the namespace nginx-API. I'm also giving it an ingress class name of nginx API. As you have seen, I need to enable this flag right now to enable the policies. It's something that is going to, I think it will be considered stable like very soon. So I also invite you to very much use them because they are super nice. So as I press enter right now, kubectl get pod-a, clear the screen. And down here, you can see this is our second ingress nginx. So I created a second ingress nginx ingress controller. It's running in the nginx-API namespace, and it's going to take care only of the ingress class nginx-API. Let's have a look at our ingress, basically. Well, it's not really an ingress, as we said before. It's a combination of a policy and a virtual server. So these are exactly the ones that I've shown you before in the slides. So the policy is very simple: rate limiting policy, rate limit, rate, key, zone size. We already talked about that. And in here, our virtual server is basically replacing our ingress. So the ingress class name is nginx-API because we want this separate nginx ingress controller to take care of it. And of course, I'm serving traffic for api.example.com, forwarding it to the service API on port 80. And in here, this is the important bit. I am applying this policy of rate limiting to this particular virtual server. Let's apply it now. kubectl apply -f demo 5 ingress API. Perfect. Now, we are at a good stage right now. We need to do a couple of more changes. In particular, one thing that I need to do is to refresh this page and change the URL. Remember, now we are going through a different ingress nginx. So I need to do minikube service list. Minikube service list, now it will show me a lot of different endpoints. Let me clear it and bring it up again. As you can see, currently we have basically 3 ingress controller running, right? So this one is the old one that we're not going to use. then we have an ingress controller for the API server and an ingress controller for my web application. In this case, as I was telling you, this dashboard is monitoring the web application. So I'm going to give it this IP, this port over here. So http://example.com, and I paste now the IP. So this is going to just ping example.com, going through the NGINX-web ingress controller. I press start, everything goes well, the application is connected. So right now, my page on the left side is just probing the web application, making sure it is connected and it's not timing out. As easy as that. Next step that we need to do is to modify our configuration for Locust, the software that we used before to basically attack, we can say, our API server. In this case, we made like a very small but very important change. Looking here, before I specified the host name in the Locust web interface. But in this case, we want to be sure that the two NGINX Ingress Controller are used independently. So what I'm doing here is specifying the name of the Ingress Controller in here. So this one is the web NGINX Ingress Controller, and in fact is making a request to example.com. And this one is the NGINX-API Ingress Controller, and is making a request to api.example.com. So I just made this little change. The deployment and the services are perfectly the same. And what this should do is that it will forward request with the same ratio as before, with the same intensity as before. But in this case, what we will have is that the requests going to the API server are going to be forwarded and are going to be sent through the NGINX-API Ingress Controller, and instead the request of my web application are going through the NGINX-Web Ingress Controller. Let's apply this manifest now. Here, kubectl apply -f demo 6. Here we go. So we applied Locust. As you have seen, the deployment hasn't really changed. It's just the configuration of our Locust script that has changed. So minikube service list. As you can see, it will show us that there is a Locust in here exposed, and with minikube service Locust, we should have our Locust web interface. As before, I'm going to move this terminal somewhere else. I'm going to keep them side by side. Remember that now Locust is going to make the same amount of requests. So in here, we're still keeping 1,000 users at a spawn rate of 50. So 50 requests, 50 users starting every second, and at peak concurrency, I'm having 1,000 users. Remember that, so the amount of requests is the same as before, but now the requests are going through two separate ingresses. In here, the host does not really matter because we have hard-coded it in our configuration. So it doesn't really matter because we have hard-coded it in our configuration file, if you remember. If I now click swarming, let's see how it goes. Oh, you see what is happening? This is a curious behavior. Since the beginning, I have a certain amount of requests that is failing. And it seems pretty constant over time, which is like first observation that you might have in here. But more importantly, on the left, our web application is still up and running and is connected and is not timing out as before. Why is that? Because the requests are going through two separate ingress controllers. So my web application is perfectly happy. My API, well, it has a fair amount of failed requests, but that's because I applied my rate limiting, right? So since I'm rate limiting the application, a person is not just allowed to go on Locust and try to kill my application by making a ton of requests, but you can see very clearly that the policy that you have created of rate limiting the request 10 per second is taking effect in here, and is making most of these requests actually fail, which is a good thing because our API is up and running and our our web application is up and running, and our API is rate limited as we wanted. One thing that I want to show you before going back to the slide is the logs. What might be so interesting about the logs? You will see in just a second. So let's have a look at the kubectl get pods -a. This lists again all the pods in the system. I want to have a look at the logs of the NGINX Ingress Controllers. Okay, let's have a look first at the NGINX-web kubectl logs-n stands for namespace, nginx-web, and then I'm saying web.nginx ingress and so on. So what do I expect to see here? Well, my web application is up and running, is happily running. It has not timed out, not even once. So I expect this to tell me that everything is good. If I click enter, of course, I get a ton of requests. But if you look at these requests, they are all successful. They're all HTTP 200. So my application is up and running, is happy, serving traffic, no problem whatsoever. On the other hand, what do we expect to see in my nginx-API ingress controller? kubectl logs-n nginx-API. API, here we go. So, sorry. In here, what I expect to see is a bunch of requests going through, a bunch of requests failing, but also my rate limiting taking place, right? I want to see and make sure that my rate limiting is functioning as it should. So if I click enter now, that's a bunch of logs, of course. And look at here. Look at this message in particular, these two messages. NGINX is telling me that it's actually limiting a request. It's telling me the zone. It's telling me the rate limit policy that I just applied. It's telling me the server, api.example.com, and the host, api.example.com. Of course, most of these requests are failing right now because I've set a very small rate limit, and I basically tried to reach it with like 1,000 users, which make most of the requests fail. But you can see in here very, very clearly that my policy for rate limiting worked just fine. Recap. So let's do a quick recap. The demo is over, but I want to just leave you with a couple of key points in case you want to look more into policies, virtual servers, and so on, and the NGINX Ingress Controller. So why you should use multiple NGINX Ingress Controller or Ingress Controllers in general, and when is it needed? So the first use case that comes to mind is internal and external application. So if you have a cluster that has certain application that you want to expose to the outside, like in this case, your web application, your GraphQL API, some classical API, and other application that you would like to expose internally to an internal network, to your VPN, and so on, like Grafana and monitoring dashboard, Kubernetes dashboard, and so on. In that case, I believe it's a good idea to keep them on two different ingress controllers. This is in order to separate the traffic between the two of them. Of course, it depends also on the workload type. So if you're having API with JWT, TCP services, web services, even in that case, it might make sense to use multiple ingress controllers. Finally, to reduce the so-called blast radius. We've seen it at the beginning of this demo, when we let the traffic go through the same NGINX Ingress Controller, even if the traffic was going to the other target, our web application was still affected. Even if the target was the API server, our web application was being affected, just for the fact of being on the same ingress controller. You have a little representation in case you want to see how does it look like when you want to expose things publicly and privately. So in this case, we have our web application exposed through Ingress NGINX to the public, and our control panel, which can be your Argo CD dashboard, your Kubernetes dashboard, and so on, exposed to your own private network through Ingress NGINX with a different ingress class. In this case, NGINX-int. The demo and the content for my presentation is over, but stay tuned because next week there are a lot of other interesting webinars coming up. The next one will be by Chris, that is here in the chat, most probably answering all kinds of questions about microservices security patterns. He has a lot of very interesting stuff to tell you, and he has also like a beautiful demo on MTLS, end-to-end encryption, and service meshes. Let me take also a couple of more seconds to share a couple of links and resources you might be interested in. NGINX.com/mm. We mentioned that at the beginning of the presentation, our blog and our website, learnkts.io. And of course, you can't go wrong if you have a look at the Kubernetes project of Ingress NGINX on GitHub. On our website of LearnKTS, we also have a nice Google Sheet that basically compares different ingresses with, based on features, supports, and so on. Please go and check it out. And finally, a couple of thank you notes from all the people from LearnKTS and NGINX. So thank you, Daniele, Jen, Marco, and Brian for making Microservices March possible. And thank you as well for attending with this webinar, staying with us. And I hope you have a lot of questions. Please write them in the chat. As you know, we're live on YouTube, LinkedIn, and Twitter as well, I believe. So just write your questions in the chat, and we will try to answer as many of them as we can. Thank you very much.
Thank you, Andrea. We have so many questions. So
wow.
I'm going to start out with one earlier in the chat from Dominic. He asked, last week you mentioned that, sorry, where did it go? Let's find it. Reading.
Thank you. Yeah, I can see right now that there are a lot of questions.
The ingress resource configurations can also be used for something like authentication. So no dedicated NGINX reverse proxy. He wants to know if you have any examples of that.
Yeah, I mean, the idea also is that one thing that we haven't shown today is that you can have like configuration per ingress, but also like per like ingress rule, but also like a NGINX Ingress Controller wide kind of configuration. So for example, you can say, I want all the traffic going through this Ingress NGINX to be authenticated. So you should prompt for authentication no matter what on every kind of traffic that goes through this ingress, or you can set it per ingress resource. So that could be a possibility. So, and you were mentioning in particular configuration which use Vouch, which is basically an external authentication system. Last week, I think I shared it in the YouTube chat, I believe, a little snippet that you can use for that. So yeah, check out the presentation from last Monday, and I'm sure you can find it. If not, I mean, at Giardini Andrea on Twitter, and I will make sure that I can share it with you.
Great. Our next question is from Nurlap. What is the recommended approach to handle high traffic to the ingress controller? Use ingress class with separate ingress controllers as you demonstrated today, or scale auto scaling like we did last week. I don't think it's necessarily one or the other, right?
Yeah, exactly. So it's definitely a combination of the two. Auto scaling, as Salman has shown like last Monday, is definitely key. So by default, if you are handling high traffic, you want to have auto scaling. Many people, what they do as well, if we are talking about really massive scale, is to also deploy Ingress NGINX as a daemon set rather than a standard deployment, so that basically as your cluster grows, also your NGINX deployment grows. That's a possibility if you don't want to do any kind of metrics-based scaling. But yeah, it doesn't go like one or the other. It's true that when you have like multiple Ingress NGINXs, in my mind, is a little bit more about separating concerns. Okay, so you're separating certain applications from others because you just want their traffic to be on different controllers, basically. So this is the idea. So definitely a mix of the two.
Okay. Next, we have a question from Ravi. How is exposing the API different from exposing the web application from a security standpoint?
Good question. I think this will be one of the topics for next week, but it depends a lot on your configuration, right? So it depends what your application is going to do. It depends what your application is going to, how it's going to be authenticated and so on. If you're referring to what we've shown today during the demo, the fact that one of them was using Ingress and the other one was using policies and virtual server, from that point of view, there is really no difference, I believe.
Okay, Matt Bowler would like to know, are the rate limited requests queued or dropped?
I believe they're dropped, because we were seeing a lot of 503 and errors. Yeah, so in that case, they're definitely dropped.
Okay, Shweta asks, so it's just like introducing path-based routing for ingress traffic. Absolutely, yes.
Mm-hmm.
There are a lot of different ways you can route traffic with NGINX Ingress Controller.
Yeah, host-based, path-based being the most, the most common ones, I would say. But yeah, most probably in the documentation, there are like many different ways you could do that.
Okay, next question from Theodore. Why are you both making separate controllers and applying rate limiting in the same step? How should we be choosing between those mitigations? And so Theodore is wondering, why aren't we doing just one thing? Why are we doing both at the same time?
Mm-hmm. Okay, I see what you mean. Why are you both making separate controllers and applying rate limiting in the same step? How should we be choosing between those mitigations? Well, it's you can give them a try. At the end, this is what we see very often. People try to find like a general rule for like every use case. The truth is that very often, like every use case is unique and special. So my suggestion is to just give it a try. Right, so you can try by having them both on the same ingress and play with auto-scaling, and that might be more than enough for you. If you have, for example, a separate an API server that requires a different kind of authentication and a rate limiting that is not needed in the other case, well, in that case, it could be better to just keep them separate.
Okay, now we have a question from Connor. If we're auto-scaling our ingress controllers, how will that affect rate limiting? So if you choose to apply both of those, what will happen?
I see. I believe I will need to get back to you on that, but I believe the rate limiting is applied per instance of the NGINX Ingress Controller. Is that
should be right? Thing? Yes.
But yeah, I mean, this whole also policies and virtual server, as I said, is something relatively new. So it's something that the team behind Ingress and NGINX has been working on for a while. And now it's, as you've seen, I had to put this flag in Helm to enable this feature. But from what I understood, it's going to be the default soon. Is that right, Jen?
Yeah, so there's two different ways to enable rate limiting with NGINX, which applies also to other use cases. So there's the custom resource that we demoed today, NGINX Ingress Resources, which is an alternative to the Kubernetes custom resource. The alternative to that would be using snippets. And while it would do the same thing exactly as we saw today, we find snippets to be okay if it's a really small use case, but it's not very scalable, error prone, etc. And so that's why we advocate for using custom resources. Because imagine if you had hundreds of backends instead of one, it could get pretty ugly really quickly.
Yeah, I remember using snippets in the past, but I was using them always or when I needed some feature that was not at the time implemented yet by the Helm chart. But yeah, I also found them, you basically with snippets, you're just writing NGINX configuration and you're telling Helm just put it inside and let's see what happens.
Shove it in there.
So it's very error prone, as you mentioned. So if you have the possibility of using annotation, custom resources, and so on, I would as well very much advocate for that. Okay.
I think we're at time. We're a couple of minutes past the top of the hour. So Andrea, thank you so much for the session today.
Thank you.
I think the live troubleshooting might have been everyone's favorite part.
Wow, I was like, I cannot believe this. So I tried it yesterday. It was working.
It only happens when the camera's on.
What can I say?
Yeah. So thank you everyone for watching. If you're interested in learning more or trying out the demo that Andrea showed us today, register for Microservices March. It's scrolling along the bottom of the screen. Drop your questions in the video and we'll do our best to answer them. That said, thank you. Have a good afternoon, evening, morning, wherever you may be.
Thank you very much. Have a nice rest of the day. Goodbye.
Bye.